everyone, so in this video I'm going to go over lesson 7, which is factoring by grouping. So this is a type of factoring that you should have been introduced to in Algebra 1. But let's first do the do now. It says, what's the first thing you should always look for when factoring? And that's always, you should be looking for a GCF, a greatest common factor. So you should always be looking for a greatest common factor to see if you can divide the polynomial by that GCF. So the best way for me to show you how to do factor by grouping is to just do an example. These are the steps written out, but I do think that I can just explain it to you and you should be able to get it. So the first example is xy plus 2x plus 3y plus 6. Now factor by grouping, you need to make sure you have an even amount of terms. Most commonly it's 4 terms. I've seen 6, but most commonly it's 4. The first thing you're going to do is you're going to try to factor it by splitting it down the middle. This is the grouping part. So I'm going to factor each side on its own. So this side here will be a separate factoring problem from this side here, and then hopefully they'll have something in common. So what I'm going to do is I'm going to take out a GCF out of here. And is there a GCF? And the answer to that would be yes, because they both have x in it. So I can take out an x and I'd be left with y plus 2. Okay. Now I'm going to think, can I take out a GCF out of this one? So if I divide this by 3 and I divide this by 3, I can take a GCF out of 3 and get y plus 2. That was a positive 3 we took out. That's important, so keep your sign. So now you should start to notice that on the left side and the right side, something's common. Y plus 2 and y plus 2. It's actually a different type of GCF, except this GCF has 2 terms. So this is called a binomial GCF because there's 2 terms here. So what you do is you can do the same process, well, as we did over here, like by dividing the x and dividing the 3, except you can divide by the y plus 2. The dividing part is an extra step. You do not need to show this step, but some people like to show it. So technically these would cancel out. You'd pull out that y plus 2, and whatever's left over, which is the x and the 3, that would be left here, and this is how you factor by grouping. To check yourself, you could just multiply these guys with box method, and you would end up getting back to the original right there. Okay, so next question is just like this. So again, I'm going to split this down the middle and see if I can take out a GCF out of the 2 pieces. Try not to make this line go over the sign right here because sometimes you can turn a negative into a positive, and we don't want to do that. All right, so we're going to look for our GCF in the first 2 terms here, and the GCF that I see here is s. So I'm going to divide by s, and that will leave me with the s coming out, 3r minus 1. Remember, when you divide by the same thing, like right here, it divides to 1. Okay, and the next side, and this side over here, what's the GCF between these 2 terms? Well, these 2 terms are both factors of 4, so I can divide by 4, and I'd be pulling out a positive 4, and I'd get 3r minus 1. And again, here's my binomial GCF, 3r minus 1 and 3r minus 1. If you want to show the division of the binomial, because that's what you're doing with both terms, you're more than welcome to, and that's what you would pull out to the front and be left with s plus 4. So the answer is 3r minus 1, s plus 4. Okay, so next question, same process. Split it down the middle, see if you can take a GCF out. So out of this first side right here, I see that I can take out a GCF of 2. I can divide both these terms by 2. And when you sorry, my 2's are starting to look like z's, so maybe I'll make them look a little different for this problem because there are z's in here. So 2 and 2. Okay, so if I take out a 2, I'd be left with z minus 4. Okay, and what can I take out of the other side? Well, they both have x's, so I'm going to pull out an x, and I'll be left with z minus 4 again. And again, though, that's where your binomial GCF is. So the whole dividing by the binomial GCF, that's like extra steps. I usually just see that these guys are the same and I pull them to the front, and then I get 2 plus x, and that's where I leave it off. Honestly, I also don't usually do this, but as you guys get quicker and better at these problems, you can start to take out these extra steps. But if you like seeing the division of this, because you know it's like canceling out in a way, just remember to pull it to the front. You are more than welcome to do that. That's totally fine. Okay, so for this next guy over here, we're going to do the same process. We'll split it down the middle. This is one of the ones that I said to be careful of the negative. Like, don't split it down and like go like this and then make it a positive by mistake. You want to make sure that you make the dotted line or the line underneath that. Okay, so I'm looking for my GCF out of the first two terms, and I see that they both are divisible by 2, so that's good. And I also see that I can divide by a b. So that I'll end up making my first term 2b. Pull out the GCF, and if I do 4 divided by 2, I get 2, and b squared divided by b is b, minus these will cancel, and be c. Okay, next side I have to divide by 7. That looks like the GCF between the two numbers, and then the two letters, or the letter that's common in both these, is d. So I can pull out a 7d. Remember to keep this negative with this term because I divided by a positive. So this is still negative c because these guys cancel, but that negative is still there. And then 14 divided by 7 is 2, and then b. Now don't freak out here. This guy here and this guy here are the same, except this is written in a different order. So you could just rearrange the order, and then you can see that this is your binomial GCF. And now what you can do is you can if you want, you can just rewrite this just so you can see them all together. And you'll see that this guy and this guy are your binomial GCF. So, oops. So pull those to the front. These guys will get pulled to the front. So it'll be 2b minus c. And then these guys are what's left over. So it'll be 2b plus 7d. All right, what else we got here is, okay, that's the last one on this page. Okie dokie. So let's keep on trucking. So kind of self-explanatory at this point. Split it down the middle. There are 4 terms because that's how you can do that. This has a GCF of a squared out of both of these. I can pull out the a squared to the front, and then I'd be left with a plus 4. Now, really the goal is that you're going to have to start to think, well, if I have a plus 4 here, I'm going to want a plus 4 here. And look at that. It's already there. So here's the deal with this one, though. You still have to pull something out because we're factoring by grouping. So you can always pull out a certain number, and that's the number 1. 1 is always a factor of every single term. So I'm going to pull out that 1 and be left with a plus 4. Here's your binomial GCF. That'll pull out to the front. And remember, it's a binomial because there are 2 terms, and it's a GCF because it's in this side and this side. So that's why it's a GCF. It's greatest common factor. All right, so let's keep it going. Split this down the middle. What can I take out of the first 2 terms? I can take out an x squared because x squared can divide into these guys. That's your GCF. Take out an x squared, I'd be left with x plus 6. So my goal is really to get x plus 6 on the other side. But if you notice, these are both negative. And don't panic just yet because in order to change the signs, you can definitely do that. Just divide by a negative. When you divide by negatives, it changes the sign. And specifically, we're going to divide by negative 4 because that's the GCF that goes with this. So if I divide by negative 4 and pull it out, I'll get x plus 6. And there you go. Binomial GCF just like we've been doing. So that'll come to the front. And this is what you're going to have as a result, because these guys will be in the other parentheses. Now, here's the deal. You've learned pretty much all the types of factoring at this point. So you have to remember to factor completely, especially when you see something with a squared. This is a big hint that you can break this guy or possibly break him up further. And we can break him up further because it's subtraction, which is the word difference. There are 2 terms, and this is a perfect square. And this is a perfect square. So this is just dots. So this is like a 2-step factoring problem. So I'll keep this guy, but I can break up x squared minus 4, I'm sorry. You can break that up into x plus 2 and x minus 2. And that's factored completely now. Okay, same process, 4 terms, split it down the middle. What is our GCF? Well, out of the numbers 4 and 8, the GCF is 4. And out of the letters, I can only take out a B and I can only take out a B. And that is because there's no C here, like that guy. And I know there's 2 B's here, but there aren't 2 B's here, so you have to be even. Okay, so 4B comes to the front. That'll be left with B minus 2C. So that means you want B minus 2C on the other one. Now, good news is you can kind of see that there's a B here and a C here, just like these guys, but the signs are different and there's numbers in front. So again, just like the last problem, to change the signs, divide by negative. What negative are we going to divide by? Well, the GCF here is 3, so I'll divide by negative 3. Pull out that negative 3, and I'll be left with B minus 2C. And there, again, is a binomial GCF. Pull that to the front. B minus 2C, 4B minus 3. And that is your factored problem. So remember, this is equivalent to this. Okay, keep it going. So I'll pull out an A squared here, because that's our GCF. I'll pull out an A squared to the front. I'll be left with A minus 2. Again, that means you want this to turn into A minus 2. Things are looking okay because you have an A in the front, just like this guy has an A first as a term. The signs are off. This is a positive and a negative, where this is a negative and a positive. So I'm going to divide by a negative. And to find your GCF out of 36 and 72, remember, you can go to your calculator and do math num and do GCD and do 36, 72. And you should end up getting your GCF that way. And the GCF for this guy is going to be, where is this problem? It's going to be 36. Okay, so 36 will go into this evenly. Okay, so you'll get negative 36 out. This will cancel, it'll give you just A. 72 divided by negative 36 is negative 2. And there you go. Binomial GCF. So A minus 2 will pull out, and A squared minus 36. See, I was thinking 12 as a GCF here, but that's not the greatest common factor. 36 is the greatest. Okay, again, just like the last problem up here, this guy up here, remember how this had an x squared minus 4? This one also has an squared. It has an A squared. And you have to think to yourself, well, if there's a squared, I could possibly break it up further. And if it follows the fact that there are 2 terms, and these are both perfect squares, and they're subtracted, this is dots. So I can break this up as A minus 6 and A plus 6, and I get A minus 2 in the front, and that's your fully factored form. I just want to double check that this guy, yep, we're good to go. Okay, cool. Moving right along. Remember, you can rewind, pause, go forward if you're, needing to with these videos. All right, so I'm going to split this down the middle, but I noticed something. There is no GCF here. 3 and 5 have no GCF, and X and Y, they're 2 different letters. So this is our first example where they're asking us to factor something that can't get factored. And what do you do there? Well, you are going to just move things right around, okay? It really doesn't matter who you move around as long as eventually you get GCFs. So sometimes I just start with switching the middle 2 terms. So I'll get 3y plus 15 minus 5x minus xy. And I'll go ahead and I'll do my GCF, my factor by grouping here. Okay, so I'll see that I can pull out a GCF here, which is 3. 3 will come out, and I'll be left with y plus 5. Here, I can pull out a GCF of 5, but if you guys notice, the order is a little off because it's y plus 5, so you can go ahead and switch this again. It's not going to solve, I'll switch these guys again just so we have the same order. It's not going to affect anything by doing that, but I'm going to divide by negative x so that this becomes, the negative x will pull out. This will cancel out to y, and this will cancel out to 5. So there you go. Here's your binomial GCF. And you'd be left with y plus 5 in the front, and 3 minus x. Is there a problem over here? Yep. Okay. How much more do we got? Only 2 more. So same dealio here. Notice these 2 terms do not have a GCF. But if I switch these guys, I may turn into a GCF. Now there is a smart way about this. You want to think of what you can do to make your life less work. So another thing you could do is switch these guys, because that'll keep this as a positive negative and this is a positive negative. So that's what I'm going to try here. I'm going to switch the second term with the last term. Okay, this will split down the middle. I'll divide by x. That'll pull out and you'll be left with x squared minus 4. That means I want x squared minus 4 over here, so I'll divide by 7, because that's your GCF. And that will make me have x squared minus 4 as my binomial GCF. That's a positive we pulled out. So x plus 7, x squared minus 4. So again, this is a squared. You want to keep in mind if you can break that apart further. Well, the answer would be yes again, because this is squared, this is subtraction, this is a perfect square. So again, this is dots. So you can break it up into x plus 2, x minus 2, and then x plus 7 pulls out to the front. Okay, one more question. And this one's a little bit larger. And if you notice, it's 1, 2, 3, 4, 5, 6 terms. And that is technically still factored by grouping, because it's an even amount of terms. I'm just going to rewrite this. Now there is a trick to doing this problem with your calculator. What you can do is plug in a number for k into this, and then plug that same number into all the other choices, and you can see which one matches. But if we want to do the mathematical way, which we all should know how to do it, you can factor by grouping by splitting this down the middle by 2's. Okay, I'm going to pull out a k squared, because that's the GCF here. I'll be left with k squared minus 4. So this kind of sets the precedent for the rest of the problem. I basically want to get k squared minus 4 for the rest. I can plot an 8k here, and that would get me k squared minus 4, because these divide by 8k. And I can pull out a 12 here, and again, that would get me k squared minus 4. So these guys are my binomial GCF. They're going to pull out together as 1. They don't pull out as 3. It's 1, because it's a GCF. And again, I'm going to ask myself, can I go further? Well, clearly you can see by all the choices that you can go further, because they're only just k's. This guy is dots, just like the one we just did. It breaks them into k plus 2 and k minus 2. And this guy here is AM. So I'll break this up into k and k. What are your factors of 12 that add to 8? 6 and 2. So I want to find the one that has k plus 2, k minus 2, k plus 6, and k plus 2. Well, I see a k plus 6 on 4 and 2. How many 2? There's double of k plus 2. So I believe the answer is 4. Okay, and that is correct. Okay, so hope this video helped. Remember to rewind, pause, stop it if you need, and I'll see you guys soon.